So here we have a circle again which circumscribes a triangle, but this time you are not given the vertices. Instead, you are given the equation of the sides. Suppose this side is given as some L1 equal to 0. This is L2 equal to 0. This is L3 equal to 0. Equation of three sides are given to us. Equation of three sides are given to us. So L1 represents the line A1x plus B1y plus C1 equal to 0. One second, someone is joining. A1x plus B1y plus C1 equal to 0. The line L2 is represented by A2x plus B2y plus C2 equal to 0. And the line L3 is represented by A3x plus B3y plus C3 equal to 0. So given the equation of three lines, how to find out the circle we will see. So for finding the circle, you can just write down an equation of second degree, because you know that circle equation should be second degree equation. So generally all these are first degree. When you multiply two at a time, like L1 with L2, L1 with L2, then L2 with L3, L3 with L1, you put some lambda before this and some mu before this. So this is a general second degree equation satisfied by ABC. So consider the equation given by this. So this equation is a second degree equation in x and y, a second degree equation in x and y satisfied by ABC. So you can say it's a second degree equation in x and y satisfied by the points ABC. But every second degree equation cannot be a circle. So definitely for some value of lambda and mu, it has to become a circle. So what are lambda and mu? Some parameters, some real numbers. So how to find that value? For this equation to represent a circle, what are the criteria we have? For the above equation to represent a circle, for the above equation to represent a circle. So what are the conditions for a circle? Coefficient of x square is equal to coefficient of y square. So we can write coefficient of x square is equal to coefficient of y square. And second criteria that you can write is coefficient of xy term is 0. So when you apply these conditions, actually when I write down this equation, what do I write in place of L1, L2? These values. L2, L3, these values. So it will be a second degree equation in x and y, which can become a circle for these conditions. So when you apply this condition, you apply these two conditions, what do you get? You will get two equations. This gives two equations in lambda and mu. Two equations in lambda and mu. On solving those equations, we get lambda and mu. On solving, we get lambda value and mu value. And you just substitute this back in the previous equation. So substitute these values back in that equation. Substitute lambda and mu in the equation that you assumed, L1, L2 plus lambda into L2, L3 plus mu into L3, L1 equal to 0. For those values of lambda and mu substituted here, this is going to represent the required circle. So gives required circle. Gives the required circle. So this is the method you can use if the equation of sides are given. So it doesn't mean that every time this equation is going to be a circle. So for parabola, there is another condition. For ellipse, there is another condition. So when we do those chapters, we can use it there. But this can be used for any equation through ABC. And for circle, I applied the criteria. Therefore, I am getting a circle. After applying the criteria for circle, finding lambda and mu, putting back the value of lambda mu here, I can get that circle. But it doesn't mean that this is always a circle only. It is a circle for some value of lambda and mu. That values we have found here by this method. So these are the two conditions with which we are going to find lambda and mu. And then we'll substitute back lambda and mu in this equation to get the circle equation. So then we have a similar concept for a quadrilateral also, circle circumscribing a quadrilateral. Circle circumscribing a quadrilateral. So we have a circle and there are 4 points which lie on the circle. So ABCD is a quadrilateral. You can also call it a cyclic quadrilateral because the points are lying on a circle. So we say ABCD is a cyclic quadrilateral. The equation of sides are, say, L1 equal to 0, some L2 equal to 0, L3 equal to 0, and L4 equal to 0. If they are giving you these 4 equations and asking you to find the circle, what would you do? So let's say they give you L1 as some line, A1x plus B1y plus C1 equal to 0. L2 has another line, A2x plus B2y plus C2 equal to 0. And L3 has a third line, A3x plus B3y plus C3 equal to 0. And the fourth line, L4, A4x plus B4y plus C4 equal to 0. But anyway, while representing, I'll write only short form, even though I wrote full lines here. So given 4 lines like this, if you want to find out a circle circumscribing the quadrilateral, the method for this is consider the equation, you multiply only opposite ones now. That is, multiply L1 with L3, L2 with L4, and just put a lambda before that. Here, one unknown is enough, equal to 0, where lambda is any real number. So this represents a second degree equation x and y passing through ABCD. So this represents a second degree equation x and y. A second degree equation in x and y through the 4 points ABCD. But it doesn't mean that every second degree equation through ABCD will be a circle. So when will this be a circle? We again have to apply the condition. So for the above equation to represent a circle, just now we wrote in the previous method, what are the criteria for a circle? The coefficient of x square equal to coefficient of y square. And coefficient of xy term is 0. So you just apply these two conditions again. So when you're applying these conditions, so here you have only one unknown. So this gives an equation in lambda and mu. And this also gives an equation in lambda, only in lambda, sorry. So they give an equation in lambda, gives an equation in lambda. And second one also gives an equation in lambda. So gives an equation in lambda. Second one also gives an equation in lambda. An equation in lambda. And once you solve these two equations, like you solve the first one, you get lambda directly. Second one also just is used for cross-checking because there is only one unknown. You don't need two of them. One is enough. So you just use for cross-checking. And then you'll get lambda value. So lambda you'll get from first one, lambda you'll get from second one. So both should match. If first one is different from second one, then it won't be a circle. So only for verification purpose, you're using second one. But otherwise, you'll get it in first one itself. And once you get the value of lambda, substitute this back in the equation. Substitute lambda in, what was the equation I assumed? L1, L3 plus lambda into L2, L4 equal to 0. In this equation, you can substitute to get the required circle. So this method is similar to previous one. So concyclic points means basically they form a cyclic quadrilateral. So if there is a circle like this and there are 4 points which are concyclic, it means the points lie on the circle. So this is cyclic quadrilateral. So ABCD is a cyclic quadrilateral. In such a case, ABCD is a cyclic quadrilateral. And we also know that if it is a cyclic quadrilateral, opposite angles will add to 180. A plus C will be 180 degrees. B plus D will also be 180 degrees. And you also have some properties, angles in same segment of a circle are equal, all that. But right now, for some problems, we need a different type of method. That is, if I join this and join this, I'll be getting two chords. They are chords of the circle intersecting in P. So for concyclic point, the criteria is the product of segments of this chord, that is PA into PC, should be equal to product of segments of second chord PB into PD. This is the condition for concyclic points. And in case if they are not chords, but they are secants. For example, you consider the secant as PAC here and PBD here. Here also, the product of the segments of this secant PA into PC equal to product of segments of other secant PB into PD is same for both. So this is the condition for concyclic points. You can remember this condition for concyclic points. So then we have another important thing related with this. Condition for the lines. Condition for the lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 to cut the coordinate axis in concyclic points. For these lines to cut the coordinate axis in concyclic points. So it's something like this. So the first line is cutting the coordinate axis like this. A here and B here. The second line is cutting the coordinate axis maybe something like this. And those points lie on a circle. So when I say condition for the lines to cut in concyclic points, what does it mean? If the first line cuts the coordinate axis in AB, second line cuts the coordinate axis in CD, these 4 points are concyclic, they lie on a circle. So clearly in the diagram, you can see what are the criteria. OC into OA, the segments. So these are secants actually. One secant, the other secant. So OC into OA equal to OB into OD is a condition for concyclic points. And if you have to convert this into the form of this A1, B1 and all, what do we do? So for the first line, what are the intercepts? So the first line A1x plus B1y plus C1 equal to 0. If you write this in the intercept form, you can write x by minus C1 by A1 plus y by minus C1 by B1 equal to 1. So the x-intercept of this is OA, y-intercept is OB. So this is OA, this is OB, you can put a mod. So OA is equal to modulus of minus C1 by A1 and OB equal to modulus of minus C1 by B1. Like that, for the second line, what are the intercepts? For A2x plus B2y plus C2 equal to 0 as the second line, you can also write this as x by minus C2 by A2 plus y by minus C2 by B2 equal to 1. So what will be the intercepts of this? OC is mod of minus C2 by A2 and OD is mod of minus C2 by B2. So then you apply the condition for concyclic points, OC into OA equal to OB into OD. So what do you get? OC or OA into OC equal to OB into OD when you write down. OA value we got minus C1 by A1 in modulus, and this value we got minus C1 by C2 by A2. This one is minus C1 by B1 and minus C2 by B2. So you see that both sides mod is there, minus sign will get removed, you will get mod of C1 C2 by mod of A1 A2 equal to mod of C1 C2 by mod of B1 B2. You can cancel out mod of C1 C2 and this will give you mod of A1 A2 equal to modulus of B1 B2. So this is a condition for concyclic points. So all this we did a derivation, but whenever they give two equations and ask the condition for concyclic points, straight away we can use this mod of A1 A2 equal to mod of B1 B2. Apart from this, what they will do, they'll ask you to find out the equation of the circle. And clearly, if you see what is the circle, basically it's a circle circumscribing 4 lines. 2 of the lines are these two. That is, this is L1, this is L2 equal to 0. What are the other 2 lines through which the circle is intersecting? X-axis and Y-axis. So this X-axis is Y equal to 0 and Y-axis is X equal to 0. So there are 4 lines through which the circle is circumscribed. What are they? L1, L2 and coordinate axis. So you can just say, if you want the circle through ABCD, suppose if you want the circle through ABCD can be written as L1, L2 plus lambda into XY equal to 0. So L1, L2 means A1x plus B1y plus C1 into A2x plus B2y plus C2 plus lambda is some unknown which you have to find out, XY equal to 0. How do you find lambda? So for circle, what are the criteria? Coefficient of x square. What is the coefficient of x square? Here A1 into A2 equal to coefficient of y square. So coefficient of x square equal to coefficient of y square. What do you get? A1, A2 equal to B1, B2. Already you know that. Okay. And what about xy term? It should be absent. XY term means you'll multiply this with this. So you'll get A1, B2 or this with this B1, A2 plus here it is lambda equal to 0. You get lambda from here. So lambda is equal to minus of a1 b2 plus a2 b1. After you get this value of lambda, you have to substitute this back here to get the circle. So with this lambda value, so with this value of lambda, we get circle as L1, L2 plus what is lambda? This value minus of a1, b2 plus a2, b1 into xy is equal to 0. L1, L2 means that multiplication I have to mention. I wrote in short form. So is this clear? So they will ask you the condition for concyclic points, or sometimes they may also ask you directly saying these lines are cutting the axis in concyclic points. What is the equation of that circle? Then straight away we can just use this. L1 into L2 means product of the lines minus of this value into xy equal to 0. So for L1, L2, what do we write? We just write this is L1 and this is L2. And does this happen for all quadrants, or will it happen only for first and third for the concyclic point diagram when you see? So this could be another possibility. Third quadrant, and you got this in first quadrant. So I wrote a mod. So for that reason, I just want to elaborate this first and third. So will you get in first and second, or otherwise in two consecutive quadrants where you can have minus sign? So here both are positive. Here both the intercepts are negative. So then also you will get same sign. So I think this will reduce to only this case. Minus sign you will not get because you will get only two cases in the diagram. You will get this case and this case. You don't get the other two cases. So this will reduce to this. Mod will not be required later. Because if it is positive, mod can be removed. Here both intercepts are positive, here both are negative. So you will get plus. Previous case, all intercepts are positive. So you will get same sign. In that case, you can neglect minus. You don't take plus or minus, you will take only plus. So from diagram, I concluded this.